Thanks everyone for joining today. Thanks for volunteering to provide technical reviews of these adverse outcome pathways. It's a really important part of the process that is organized by EGMIST and really helps establish the credibility of the information that is being captured in the AOP wiki. So we really appreciate your time and interest in doing this. So as you review the AOPs that you'll be looking at, there's basically 3 charge questions that you'll be assessing. The first of those really relates to the scientific quality. Does the adverse outcome pathway incorporate the critical scientific literature and evidence that provides support for that pathway? And does that scientific confidence really reflect current scientific knowledge on that topic area? To the extent possible, also that scientific knowledge gives a objective sort of representation, considering both support and evidence in the scientific literature that may be inconsistent with the AOP. Second question or charge question really relates to the weight of evidence and how the developers have assessed that weight of evidence and supported their rationale for the weight of evidence scoring that's captured as part of the AOP description. So really looking at whether the judgment or the basis for those scores is well defined and justified based on the evidence presented. We want to consider that for each relationship as well as the adverse outcome pathways as a whole. And then the third charge is really to provide any additional observations that you have that may be helpful to the developers. So any observations about things like where there might be some critical data gaps or information gaps in the AOP that could be maybe addressed, or particular applications that the AOP may be well suited for, any additional information that you feel would be helpful to the developers. So those are really the 3 main things that you'll be looking at as you evaluate the AOP. So I know, based on the names I see, some of you are very experienced with AOPs, with the AOP program. Some of you may be a little less familiar. So what I wanted to do today with this presentation is just give a very brief introduction to AOPs, just to give a little bit of background for those who might not have done this before or may be less familiar with the AOP framework. Revisit the principles of adverse outcome pathway development, because they'll certainly impact how the information is organized onto the pages that you'll be reviewing and some of the things that you'll be seeing as you review those pages. I'm going to go over the 3 main page types that you're going to find. So if you're looking at the snapshot hard copy version of these AOPs, information will be structured in basically 3 different ways depending on the page type. If you're actually looking at it in the wiki, again, these are different page types that you'll find in the AOP wiki. And then we'll spend a little bit of time discussing the guiding questions that are used for the weight of evidence evaluation. This is basically the set of questions that the authors are referring to when they assign weight of evidence calls of low, moderate, or high in terms of the evidence supporting the different relationships in the AOP. And then finally touch on a couple of concepts related to balancing the technical quality and accuracy with simplicity and usability for the people that would want to use this information. So that's kind of what we're going to try to cover over the next 30 minutes or so. So first of all, the adverse outcome pathway framework. By definition, an adverse outcome pathway is just a conceptual framework that portrays existing knowledge concerning the linkage between some molecular initiating event, so where some stressor interacts with some molecule in the body of an organism, causes a perturbation in the normal biology that then can progress across different levels of organization to result in an adverse outcome that we actually consider relevant to risk assessment, regulatory decision-making, management practices, and so on. And so, we've assembled information on sort of modes of action of toxicants, mechanisms by which toxicity can occur. That's been done in toxicology for many decades. But really the need to assemble this information and make it available through a knowledge base is driven in large part by changes in the toxicity testing paradigm that are really emphasizing use of critical mechanistic endpoints that are involved in the induction of overt toxic effects rather than directly measuring apical adverse outcomes themselves. So as we try to move away from our heavy reliance on animal testing, as we try to move to more efficient and cost-effective methods to screen lots of chemicals for potential biological activities and potential toxicity, we create a need then to really understand the biology and describe the biology in terms of how these biological perturbations of biochemical pathways of molecular signaling can actually lead to the adverse outcomes that we care about from a risk assessment standpoint. And so as we try to use these new sources of information, the challenge that a lot of decision makers, risk assessors, regulators, and so on face is that they need a lot of access to specialized knowledge to really interpret the data that are coming out of these alternative approaches. And so the challenge they face is a little bit like us going to the doctor and having some diagnostic tests run, then the doctor just handing you the results. It's difficult to interpret those without the specialized knowledge that doctor has in terms of understanding, what these various blood measurements might mean for your health. And so the people trying to interpret data from these new approach methods face a similar challenge in trying to understand what these data mean in terms of toxicity outcomes and how to interpret that. And so these are all smart people, and a lot of the information they need to interpret what those results might mean are out there in the scientific literature. They're in textbooks, they're in databases and other types of information that have been assembled. But there's a lot of information that's out there, and sifting through it, pulling together the right information that helps us to understand what these alternative data streams might mean is a fairly laborious and time-consuming task. And so what they really need is sort of efficient access to the pertinent information that helps them utilize the information they have on hand, make the kinds of decisions, extrapolate to kinds of decisions that they need to make. And so sifting through this sort of overload of information, capturing this information that's widely dispersed in all these different sources, and then trying to bring that together in a more concise, clearly communicated fashion that's still scientifically supported and credible. That's really a lot of what adverse outcome pathway development is about. So this is just an example of an adverse outcome pathway. Here we have a molecular initiating event, inhibition of a particular enzyme. Based on what we know about normal biology, we know that this particular enzyme is rate limiting for the production of a hormone. We know that that hormone plays an important role in stimulating the production of egg yolk protein production, for example, in egg-laying vertebrates, and that production of that protein is critical for proper oocyte formation, as well as providing nutrition to the developing offspring, and which, of course, having good quality eggs and nutrition for the offspring is then needed for successful reproduction. And so this basically lays out our understanding of the normal biology that this enzyme plays a role in, that these hormones play a role in. And so just based on that understanding, we could at least draw inference that if we were to inhibit this enzyme activity, we could potentially negatively impact the production of this hormone and all these events that rely on the production of that hormone. And so that provides some basis for thinking that if we inhibit this enzyme, we could impair, for example, reproduction. So the AOP captures that information, lays it out in a very easy to follow sort of box and arrow diagram. But not only does it capture that information about the basic biology, but it also captures empirical evidence that actually supports these relationships, that show that if we inhibit this particular enzyme, we do see decreases in the production of these hormones. We do see decreased uptake of these egg yolk proteins into the developing oocytes, and that we actually see impaired reproduction. And so as we assemble this kind of information and capture it in the AOP wiki, we have the basis to understand, again, what these perturbations early in this pathway might mean in terms of the apical outcomes that we care about. So we can do this for many different pathways. We can assemble these basic linear AOP descriptions into broader networks where we consider not just one pathway, not just one perturbation that can lead to an adverse outcome, but a whole range of different perturbations that may converge on certain key events. So for example, here the production of thyroid hormone, and how these different types of perturbations may converge here and result in certain outcomes, or possibly result in different outcomes depending on the species we might be looking at, depending on life stage, sex, and so on. And so there are many different applications for this information. Again, interpreting data from these new approach methods, but also understanding, for example, if we were seeing impacts on amphibian metamorphosis, tracing back to say, well, what kinds of contaminants could cause these effects? What types of targets might those contaminants interact with? How might we design a battery of alternative tests to cover this range of possibilities? And so those are just a couple examples, but there are many more different applications for these adverse outcome pathways. And it's important that these be based on good, credible scientific evidence so that the regulators, the decision makers can feel confident in using this information. So as this information is assembled in the adverse outcome pathway framework and in the AOP wiki, using the framework, there are basically 5 principles that underlie how the information is organized, how it's presented, how we sort of capture the information. So I want to briefly go over those because they'll certainly impact what you see as you review these documents. So the first principle of AOP development is that adverse outcome pathways are not stressor specific. So we're not necessarily trying to develop an AOP for, say, a particular organophosphate pesticide, for example, but we're trying to describe what would happen if any particular chemical perturbed this particular aspect of the biology. So we're trying to describe generalizable biological motifs of failure that can be applied to a wide range of stressors that act on that same target. And so we may want to understand what types of chemical structures can actually cause that perturbation and elicit these particular biological responses, but the AOP itself is not specific to any particular stressor. The second principle of adverse outcome pathway development is that adverse outcome pathways are modular. So we break down AOPs into 2 basic units of information. One we call the key events. These are measurements of the biological system that we can make. And the second are the key event relationships. This is the scientific evidence that supports if we see one particular change in the biology, we can expect to see some other change based on what we know about how that biological system functions. The third principle of adverse outcome pathway development is that the AOP itself, or the linear sequence of key events that makes up a particular adverse outcome pathway, is viewed as a pragmatic unit of development and review. in that it's the simplest unit of application. It connects one of these molecular level perturbations, a molecular initiating event, all the way to an adverse outcome. Again, things that we care about from a decision-making standpoint. And so, practically speaking, it's the smallest unit that's actually useful. And it's a tractable unit that we can actually assemble information for and conduct a review for. We know that if you perturb, say, an enzyme involved in hormone synthesis, there may be multiple things that can happen as a result of that. We don't necessarily capture all of those possibilities in a given AOP. We focus on linking one particular initiating event to one particular outcome. But as you do that, that's a tractable amount of information to assemble and review. With that in mind, though, we recognize that the biology is more complicated and that you can have these multiple outcomes that may occur as a result of perturbation. We capture that. We can assemble adverse outcome pathway networks based on shared key events, key event relationships. And these AOP networks then are really the practical unit of application for most real-world scenarios where exposures may be to mixtures, so you have multiple perturbations happening at the same time, and where you have even exposure to single chemicals that may perturb multiple targets. You need to consider the spectrum of different effects that can occur and how those might interact with one another. And then the final principle of AOP development is that adverse outcome pathways are living documents. So again, an AOP is just a way of organizing information. And so as new information is generated, as we learn new things about biological systems, as we generate new evidence concerning how certain perturbations affect the biology, we can continuously update these adverse outcome pathway descriptions. So again, the basic building blocks of AOPs that we refer to are the key events. So these are measurements or measurable changes in the biological system that occur in response to different stressors. We talk about two specialized types of molecular initiating events, one being the molecular initiating events. So this is the initial point of interaction between the chemical and the biological system. It really starts the AOP. And then the adverse outcome, specialized key event in that, again, it's relevant to decision making. So this is actually you want to end our AOP at this level. We can combine any pair of key events along with scientific support for a causal relationship between them to form a key event relationship, which are basically represented as the arrows in these box and arrow diagrams. And again, we string together a sequence of those key events and key event relationships to form an AOP that connects the molecular initiating event to the adverse outcome. Those three basic units of information are represented as separate page types in the AOP wiki and in the snapshots that are prepared from the AOP wiki. So there are certain pages that are associated with the events and describing these measurements of the biological system that we make. There are separate pages that then capture weight of evidence that links one key event to the next or to another in the pathway. And then there is an AOP page that provides that overarching sequence of events and overarching evaluation of the total weight of evidence supporting extrapolation along that pathway. So after introducing a little bit of background about the AOP framework itself and the basic units of information that we're trying to capture, I wanted to touch a little bit on the types of information fields that you'll see on each one of these pages, because again, as you review the documents, this is how you're going to see the information organized. You may see some redundancy between some of the key event and key event relationship pages, again, because the relationships are connecting together two of the key event pages, so they have some common biology that's being described. But basically on the key event pages, Each key event, again, is some observable change in biological state. It's a measurable event. It helps to mark the progression from initial perturbation of the system toward development of the adverse outcome. And each of these key events is considered essential, such that if this event didn't occur, none of the subsequent downstream steps would actually happen unless they were triggered through a separate pathway that intersects. But they're also not necessarily sufficient. Just because we see one of these early in the events in the pathway happening doesn't mean that the system's been perturbed enough that it's going to progress all the way to the adverse outcome. The basic information that's captured on these key event pages, there's a number of structured fields. These are usually fields that are from drop-down menus using controlled vocabularies, and they're basically machine-readable fields that you can query with a computer. This captures things like controlled vocabularies or ontologies that try to describe what it is this key event looks at. And there's a listing of all adverse outcome pathways that already include that particular key event, because again, these key events can be shared among multiple adverse outcome pathways. And then there are a variety of structured fields that try to describe the domain of applicability in terms of level of biologic organization, life stages, species that this event is relevant to, and then any stressors that are known to perturb this key event, particularly if it's a molecular initiating event. You'll also see free text fields that basically provide three pieces of information. Basically a description of what it is we're measuring when we look at this key event. Second, how we measure that key event in terms of methods or assays. The more we can define specific assays or measurements, the better in this section. And then finally, the domain of applicability. So what species, sexes, life stages is it actually relevant to make this measurement for? Second major page type that you're going to find are the key event relationship pages, or just relationship pages as they're described in the wiki. Again, this is basically the arrows that connect any pair of key events together. These are basically the functional unit of inference or extrapolation along an AOP. They define a directed relationship, so they say that A causes B to happen. And we're assuming causal relationships are involved. And basically what these relationship pages do then, they define these two events and provide evidence that there is a causal relationship between those, and define the conditions under which that causal relationship actually applies. So once again, you'll find structured information at the top of the page, so it'll identify the two key events that are being connected. Each of those should have a key event page associated with it already. It'll have a list of other AOPs that may already include this relationship, and again, various structured information that tries to define the domain of applicability. The free text portion of the page then tries to lay out the various lines of evidence that support this causal relationship between event A and event B. And that's laid out in terms of biological plausibility, empirical support, our quantitative understanding, and the domain of applicability. So the relationship pages are really important to evaluating the scientific quality of the AOP. They're really the place where most of the weight of evidence supporting an AOP is actually captured. Each relationship is described in a modular fashion, so what you find on the relationship pages should really speak to just one binary pair of key events. How the inhibition of a particular enzyme affects production of the hormone. It's not going to speak to all the different steps in the pathway. It's going to speak to this particular pairing. So it's again important to remember that these relationships are not chemical specific. So we could support this relationship using experiments from a wide variety of stressors or experimental manipulations. And it's important to bear in mind that those experimental manipulations or stressors may not even be relevant to the specific AOP in question. So just because our AOP may focus on inhibition of this enzyme, that doesn't mean we can only consider stressors that activate a particular initiating event upstream of this. Data from other stressors may still speak to what happens to this particular endpoint, what happens to this endpoint, and how those two are related. So may see some data that's not directly relevant to the molecular initiating event for the pathway that you're looking at, but that doesn't mean it's not relevant weight of evidence to support this particular relationship. So in terms of the types of evidence that are assembled on these key event relationship pages, one of the types of evidence is basically the plausibility. So this is basically evidence that's based on what we know about normal biology. So is there some known structural or functional relationship between event A and event B? Some examples of this would be, for example, if the upstream event was some enzyme activity that's being measured here, that enzyme plays a role in a reaction that actually forms the product that's measured in B. So this is the example I gave earlier of, for example, an enzyme that catalyzes the production of a particular hormone. That would be a known structural and functional relationship between these two. Another example would be if the product measured in A actually forms a structural component of an organ examined in B. So for example, if this is collagen formation and that collagen actually makes up structure of this tissue, that could be a basis for plausibility. Or if you have, say, a tissue measured in A, if A is, say, production of a fin or generation of the heart, and then B is actually a measurement of the function of that tissue. So if we impair the production of a fin, you may impair swimming behaviors in a fish. If you were to impair development of the retina, for example, you might impair a function of the eye. So this is a structure that makes up the eye, for example. So that's the kind of support that we're pulling together in terms of the plausibility to support these key event relationships. The second line of evidence, or lines of evidence that we really consider are the empirical support. And this is really looking at after experimental manipulation that actually causes a change in event A, do we see a change in event B, and do we see it in a manner that's consistent with a causal relationship? So we look at, for example, is there temporal concordance? So do the changes that we see in event A actually precede the changes in event B? We look at dose concordance. So are there effects on event A at concentrations of the stressor that are equal to or lower than those that produce effects on event B? In terms of incidence concordance, do we see event A impacted in a greater proportion of the population than those that we see event B impacted? Again, recognizing that event A is essential but not necessarily sufficient for B to happen. And what is the overall consistency of these responses across the data that are assembled? Once we've assembled that weight of evidence, the developers then provide a score indicating high, moderate, or low confidence or low weight of evidence supporting that particular relationship. And that is, again, based on these defining questions considering the plausibility, whether there's this mechanistic, understood structural or functional relationship between those events that's consistent with the established biological knowledge, and what the empirical support is in terms of, again, looking at the concordance of the two relationships. Does that pattern of evidence fit a causal relationship between event A and event B? Those considerations of plausibility and empirical support, additional evidence related to the essentiality of that key event or specificity in the pathway are then brought together to do an overall weight of evidence evaluation, bearing in mind that plausibility is really considered sort of the strongest independent line of evidence, with empirical support being the weakest. You can sort of think about this as, you know, when you have small amounts of empirical support showing that if I perturb A, something happens to B. If I understand what the mechanistic relationship is between those two events, I don't need a lot of empirical support to have confidence in that relationship. However, if you just have observational data that show that I saw a change in event A and then B happened, but you don't really understand why that connection is there, maybe just correlation based, it takes a lot more empirical support to establish high confidence in that relationship. And overall, the more specific that relationship between A and B, the less other factors that could influence it, the greater confidence you have in that causal relationship. So again, it's bringing these various considerations together to make that final assessment of the weight of evidence. Second thing you'll find on the key event relationship pages is a description of the quantitative understanding of this relationship. We try to capture that in terms of 4 considerations, but the overarching goal is to define what is known about how much change in event A and under what conditions is actually needed to evoke some unit of change in B. We then try to describe that in terms of a response-response relationship. So define a function or model or plot that actually describes the change in B as a function of some measurement of A. Try to describe the time scale. So how long after A is impacted do we see the effect on B? Is that seconds, minutes, hours, days, weeks? That's important to understand how we might need to structure an experiment if we want to measure these two things. We're looking at the literature. Is it relevant to see, or could we expect to see the effect on B at time scale that was actually looked at in the experiment, and those types of things. Another consideration is there known modulating factors. So what internal or external variables are actually known to shift or alter the nature of this relationship? Does the relationship between A and B depend on what I ate for breakfast? Does it depend on my genetic background? Does it depend on whether I have a pre-existing disease state or not? If we have that kind of knowledge, we try to capture that here. And then any known positive or negative feedback loops where we might have information that suggests that A causes B to happen, but that when B changes, it can actually in turn feedback and influence what's happening with A, which can lead to much more complex dynamics between these two events. And so if we know something about that type of feedback, we'd want to capture that information as well. In evaluating the level of quantitative understanding, again, we have a series of defining questions that help guide the developer as to whether to rate this low, medium, or high. It basically speaks to the level of precision with which we could predict what happens to B based on some measurement of A. So if we can only do that at a qualitative or semi-quantitative level, we would consider that low. If we can actually precisely predict what would happen to B based on some measurement of A, but we maybe have some uncertainty associated with some of these modulating factors or variability, we might rank it moderate. If we can predict with very precise or very precisely and understand the various sources of uncertainty or variability in that measurement, we would then rank it high. Once we've assembled all the information on the key event relationship pages, the AOP page then pulls that together into this overall sequence. You'll see a graphical overview of the pathway, a brief abstract describing what this AOP is all about, what's the initiating event, what's the outcome, what are some of the major steps in between. You'll see a summary of tables of the key events and key event relationships that are involved, and a network view that shows how these events might be shared with other AOPs that are connected to it. and structured fields for the domain of applicability. Again, this AOP page links together that whole sequence. Important to note, it can include both adjacent key event relationships, so basically one event leading to the next in the pathway, but we can also have relationships that skip over some of these intermediate events. That allows us to keep the modular aspect of how the information is captured in the knowledge base, but also allow us to capture evidence that may measure just these two events. So hormone production and the effects on high-level effects on a tissue, for example. There are other steps in between that establish the biological plausibility of this relationship, but there may be measurement data from empirical studies that just speak to these two events, or maybe these two in the pathway. So we want to be able to capture that. Basically, the AOP page helps to define the fit for purpose of the AOP for different applications based on overall scientific support, potential gaps or limitations in our understanding, and the domain of applicability of that AOP. And so on the AOP page, you'll see an overall assessment where the developers should provide a narrative and rationale for the domain of applicability of this overall pathway, the rationale for the weight of evidence calls that they've given, an assessment of the overall quantitative understanding across that pathway, and then taking these into consideration, potential applications of that AOP. So the AOP page then can be really viewed as a place for synthesis of the information, looking at how well that overall story hangs together, and it's a place for evaluation of what are the strengths and the weaknesses of that particular AOP. So that's kind of an overview of the different page types, what types of information you'll find there. Just some additional considerations. Adverse outcome pathways are intended to synthesize specialized knowledge and make it simple and accessible for non-experts to understand. And so to that end, AOPs employ what could be described as a simple box strategy. We're making a simplification of a very complex biological system. We're trying to represent dominant processes in that system, but ignoring many of the details that aren't necessarily critical to use. And there's a bit of an art to deciding what are the important details, what can we sort of leave out of that description. As you look at the AOP and the key events, the type of information that's captured in the key event relationships, for nearly all of these, there's a lot going on under the hood. So for example, this key event relationship linking dopamine release in the brain to locomotor activities, there's a lot of different signaling events that mediate the effects of dopamine on the movement of the animal. Do we really need to capture every step of this signal transduction cascade and the signaling in between, or can we capture these dominant processes based on these particular events? So again, part of the art of AOP development is really selecting what details to include versus what to ignore. And it's important to recognize that this is a somewhat subjective process. There's not necessarily a right or wrong. There are different ways to view it. And so it's trying to find that right balance between lumping and splitting the information. Ultimately, an adverse outcome pathway is a communication tool. And so it's important that the information be communicated clearly and in a way that other people can use it. So providing very strong scientific support for an AOP doesn't do us much good if only people that have very highly specialized knowledge, are experts in a particular field, can actually understand what's being presented. So effective AOP descriptions will avoid the use of highly specialized jargon, define relevant abbreviations, should strive for brevity, and aid in readability by organizing content into subsections, using bulleted and numbered lists, making effective uses of tables, figures, illustrations, etc. If you find yourself really struggling to understand the information or how that information is organized, chances are other users are going to struggle with that as well. So providing that feedback and helping authors to make these descriptions highly readable and usable by others is an important part of this process. Finally, again, AOPs are living documents, and key events and key event relationships that make up an AOP may be shared by multiple adverse outcome pathways. So as you review these AOPs, you actually may see contributions from multiple authors that may come from previous AOP development projects that shared that same key event. So you may see some inconsistencies in style. Different authors maybe present or organize the information in a slightly different way. Some lines of evidence or the species may be more represented than others. And some of the content may be more relevant to the specific AOP you're reviewing than others. Because again, some of that content may have been from a previous AOP development that shared some of those same pages. So it's important to sort of bear that in mind. So getting back to your charge, in terms of evaluating the scientific quality of the AOP, the relationship pages are going to be the primary page type where that scientific support is captured. And again, AOPs need to sort of balance that detail and the scientific nuance of these biological systems with clarity and communication and the utility of the AOPs, not providing so much detail and so much nuance that you can't actually use the pathway. Again, weight of evidence. The AOP page is the primary location where the developers explain the rationale for the weight of evidence judgments or scoring that they provided. The details are on the key event relationship pages. The AOP page outlines the rationale for why they scored it the way they did. And again, there's inherent subjectivity in what scores are assigned, but those scores should be based on the guiding questions that are outlined in the user's handbook. And finally, in terms of additional observations, this is a good place to consider how effectively that overall AOP is communicating that specialized knowledge to a non-expert audience. Are there ways that the communication of the scientific information could be improved? Have the authors really made this as simple as possible, but not simpler than it needs to be in order to provide good information? And can we identify key data gaps or other information that may help fill this in or identify appropriate applications for the AOP? And so that's a very quick overview of sort of the charge, how the information is organized, and some things to consider as you look at your AOPs. Again, thank you for volunteering to do these technical reviews, and be happy to answer any questions that you might have.